credited to be founded by Pythagoras, who was a Greek philosopher and mathematician. And again, this theorem is only going to work for right triangles. So first of all, we need to know that a right triangle has certain side lengths and certain names for the side lengths. The two sides that make up the right angle in a right triangle are called the legs. And then the measurement that is across from the right angle is called the hypotenuse. And so what we're going to look at is how those side lengths are all related and then how we get the Pythagorean theorem. So the Pythagorean theorem says that a squared plus b squared equals c squared. And where a and b are going to represent the legs, and then c is going to represent the hypotenuse. So what this means is that the area of the square built off of the hypotenuse is going to equal the sum of the areas of the squares built off the legs. So let's look at this visual representation here. We have our right triangle in the middle, the yellow right triangle. 3 and 4 are representing the legs, whereas 5 is going to be the hypotenuse. So we can build these squares off of the legs. And if I build a square off of the side length with the 3, you guys can see that the area of that square is 9. And then I can do the same thing over here. My area of this square is 16. So it has a side length of 4, which means that the area of that square is 16. And so the sum of those two squares will equal the area of the square that's built off of the hypotenuse. So if I look, here's my 9. I could do my area of 9 here. All right, there's that smaller square. And then plus another 16. So if I add 16 to that, so there's 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. The sum of those two smaller squares is equal to the area of that bigger square. And so we get our Pythagorean theorem is a squared plus b squared equals c squared. So let's go ahead and try to actually use that and see what we get here, okay? First of all, we're going to look at example 1. So it says a right isosceles triangle has legs 6 meters long each. Find the length of the hypotenuse to the nearest tenth of a meter. So in our Pythagorean theorem, we always start by writing it out. A squared plus b squared equals c squared. A and b are the legs. C is always going to be the hypotenuse. So this is telling us our legs are both 6 meters long, and we're trying to find the hypotenuse. So I would write something like that. Then I can say, okay, well, 6 squared is 36, plus another 6 squared is 36. And I know that has to equal c squared. And so 36 plus 36 is 72. So 72 is equal to c squared. Then I can take the square root to figure out what c would be. And then we will be using calculators here, and we're going to just round to the nearest tenth. So the square root of 72 is about 8.5 meters. So then my answer here would be about 8.5 meters. Here's another example. So on this example, we're actually given the hypotenuse in one of the legs. So I'm going to start with a squared plus b squared equals c squared. And then we can plug in what we know. So in this case, my hypotenuse is 13. So that has to be plugged in for c. As far as the legs go, they're interchangeable. So 8 has to go in for either a or b. It doesn't matter where. So I get a squared plus 8 squared equals 13 squared. And I suppose if I wanted to, since my other leg is called x, I can do that. So x squared plus 8 squared is 64. 13 squared is 169. And so now I have an equation to solve. So I'm going to end up subtracting 64 from both sides, and I will get 105. so x squared equals 105. So now I need to take the square root of 105, which will be a long decimal, and so we're just going to round to the nearest tenth and say it's about 10.2 feet. So we're using that equation and plugging in what we know to figure it out. All right, we can apply the Pythagorean theorem in different ways as well. So over here it says find the length of the diagonal. So we have a rectangle. The diagonal is what's going across the middle right here. Well, if we look, this is a right triangle. All right, it's a rectangle, so we have 4 right angles, so that means here's my right angle. And I can use the Pythagorean theorem again, a squared plus b squared equals c squared, to figure out the length of the diagonal. So my legs are 4, so 4 squared plus 11 squared is going to equal c squared. And then we evaluate, so 4 squared is 16, plus 121 is going to equal c squared. I can add these up, I'll get 137 equals c squared, and then I can take the square root of 137, which is going to be about 11.7 inches. So we're using our calculator. We're still going to focus on showing our steps for solving this equation. So on this next part, the theorem can work both ways. So if a triangle is a right triangle, then we know that a squared plus b squared will equal c squared. And also, if that equation is true, so if the sum of the 2 shorter sides squares is equal to the longer side squared, then that triangle is a right triangle. So we can use that to figure things out. So here it says we have side lengths of 8 centimeters, 10 centimeters, and 16, and I want to try to figure out, okay, is this a right triangle? So I use the Pythagorean theorem, and then I'm going to plug in my 2 shorter sides for A and B. They will always be the legs. The longest side is always the hypotenuse. And so now I'm proving whether or not this is a true statement. So it's like a question mark. And when we do that, (16 squared is 256, 64 plus 100 is 164. And we're going to say, oh, well, 164 does not equal 256, so no, that cannot be a right triangle. And then we can now also apply the Pythagorean theorem to find the distance between different points. So here it says find the distance between the points 4, -3, so 1, 2, 3, 4, 4, -3, and -2, 1. And I want the distance between those points. All right, well, that looks kind of tricky to try to like just count. I don't really have good spaces that I can just count up. So what we can actually do is we can create a right triangle that then allows us to figure out what that distance is. So now that blue line is my hypotenuse, and I have legs of my right triangle that I can use. So this distance here would be 4, and then my bottom leg here is 6, and so I can say, okay, well, a squared plus b squared has to equal c squared. My legs are 4 and 6, so 4 squared is 16, 6 squared is 36. This is going to give me 52, and then I can take the square root of 52 to figure out that my hypotenuse is we can either leave it as the square root of 52, or we can say it's going to be about 7.2 units. So those are just a few of the different ways that we can use the Pythagorean theorem. Have a great day.